Oh, perfect. All right. Well, today we're going to do 6.2, when we're going to talk about the characteristics of parallelograms in class today. So first, our objectives are to verify and apply the properties of parallelograms. And two, we're going to apply the congruent division of transversals theorem, which, actually is probably going to be more of a no. We won't do that because I'm going to talk while I'm working here to get my tools back. The way that we were going to apply it, or the book has you apply it, is simply to construct it, and I don't see a reason for us to spend the time doing the constructions always. I'd rather focus on the other material. So we may not actually get to objective 2. All right, but here is some cool stuff about parallelograms, and naming them is super important. So when a parallelogram is named using notation such as, right, the important thing is that we've got this parallelogram notation, A, B, C, D. We can conclude some things from that because it's telling us it's a parallelogram. So we can conclude that AB is parallel to CD. All right, so I'm going to go ahead and draw those in. And we can conclude that AD is parallel to BC, because they've told us it's a parallelogram. So when it comes to like doing theorems, or like when it comes to doing proofs, pardon me, that is one thing. Like when you're given a parallelogram, you can automatically say, well, these two sides are parallel and these two sides are parallel, because it's a definition of a parallelogram. Okay, because to be a parallelogram, we know the sides have to be equal, or they have to be parallel. Oh my gosh, if I could get my words straight today. All right, so then we have several theorems to start us out with that we can also make conclusions on. So the whole front page is pretty much all theorems, pretty much. Okay, so let's look at all of these. They don't have any special names. They're just things that we know. So consecutive angles, what does consecutive mean? We talked about that yesterday. 1, 2, 3, 4, 5 is consecutive. Right beside each other is consecutive. So consecutive angles of a parallelogram are supplementary. What's supplementary? 180. Okay, so if you need to write that in there to help you remember, so they're going to equal 180 degrees. So if I go back, if I get this, what angles are supplementary here in parallelogram A and B? Okay, so angle A plus angle B is going to equal 180. No, you don't have, you can. There's no reason, I mean, you could write it down with that. It doesn't matter. But angle B plus angle C equals 180. Any two consecutive angles are going to be 180. So that's pretty cool. Okay. The next theorem, opposite angles of a parallelogram are congruent. Okay, so what are my opposite angles? What's opposite of A? C. And what is opposite of B? Okay, so B and D are congruent. We can conclude that. These are things that we know. Okay, the theorems are telling us as well. And so anytime we're given a parallelogram, we have a lot of things we can write down from some very simple theorems. You're never done with triangles. Triangles are like the basis of every shape we have. So you're never done with triangles. Sorry. I know, right? Quad angles are important, but not that important. Okay, so the next one, if a parallelogram has one right angle, so I'm down here, just barely on there, then it has 4 right angles and is a rectangle. So that's kind of cool, right? If we're told that it's a parallelogram with 1 right angle, then we can use this theorem and say, oh, well, then it's a rectangle. So if we said parallelogram E, F, G, H, and we're given, say this is what we're given, angle H equals 90 degrees. Okay, so if we know this, well, if one angle is 90, then, so if this is angle E, F, G, H, if this angle's 90, the thing is a rectangle. because H and E, pardon me, here, have to be supplementary, so they have to add to be 180. H and G are also supplementary, they have to add to be 180. Opposite angles are equal, they have to, so if this one's 90, this one has to be 90. But if this one's 90, to be at 180, this one's 90, and this one's 90. So if we're given that it's a parallelogram and an angle is 90 degrees, well then we can say, oh, it's actually a special parallelogram. It's a rectangle. Okay. All right, let's look at the next one. And the last one. The diagonals of a parallelogram bisect each other. So what's a diagonal? Yes, you do. It cuts through it from corner to corner, right? Opposite corner to opposite corner. Okay, well. In a quadrilateral, yes, it's opposite angle to opposite angle. But diagonals can be in other shapes, like a pentagon, and you can have lots of diagonals. They can't go to a consecutive angle. It's a diagonal goes to a non-consecutive angle. So anyway, so this is a diagonal, and this is a diagonal. Okay, it says the diagonals bisect each other. So let's call this M in here. So what does that tell me about AC and AM? Or sorry, AM and CM.
They're congruent.
Okay, they're congruent because they bisect each other, so they're cutting each other in half. So A to M is congruent to M to C. All right, what does it tell me about DM and BM? They're congruent to each other, okay, because they bisect each other. Now here's a question. Is AM, it does kind of look like a kite, you're right. Is AM congruent to DM? No. Okay, we don't. Okay, so this is a big fat no, right? It's not congruent. We cannot make that conclusion, okay? And if we look at it, they don't look congruent, but we definitely can't make that conclusion. That would only be if the sides of the parallelogram were equal. So if it was a rhombus, would that be the case? Okay. So, but yes, it is important to know that they do bisect. So each half is equal to the other half. Awesome. Okay, so let's start putting all these theorems, because there's 5 theorems there. It's like, whew, overload, into practice with example 1. So find each measure in parallelogram ABCD if BD equals 11.6 meters and the measure of angle ABC equals 72 degrees. Okay, so first of all, we're gonna, we might need to use all that, but let's see if we need it for the first one. So we want to find DC, the measure of DC. Why is it 6.3? Because it's the opposite of AB. Okay, so it's 6.3. Good. All right. How about E to C?
4.2.
So now we want E to C. Okay, does anybody agree with 4.2? Okay, why, Lucas? I heard you say mm-hmm.
Because it's the opposite of AE.
Okay, so it's AE and EC. Okay, it's the diagonal of the parallelogram. Okay, and it's being bisected. So each of those are congruent. Awesome. So EC, I'm going to write here even, is equal to AE, which is equal to 4.2 meters. And DC was equal to AB. We might put that. These are just extra notes to kind of help you if you need. All right, how about then ED? 41 is the degrees. That's the angle measure. But we do know, see, that's because we don't have a measure for BE, but we do have this. We know BD, that whole thing, is 11.6. What's half of 11.6? That's good. Yes, because we're going to cut it in half because this was it was bisected. So what's half of 11.6? So this equals half of 11.6, which is, what's half of 11?
5.5.
5.5. Okay, so we've got 5.5.
Yeah, it is 6.1.
And then what's half of 0.6?
3.
Okay, so 0.3. Yep.
5.8.
So it would be 5.8. So this is 5.8 meters. Awesome work. All right, so now we're going to get into the angles measurements. So what's the measure of angle DAB? So, whoops, let me get my pen back here. So from DAB.
Is it 72 as well?
Right,
The
DAB.
opposite side.
Because ABC is 72. So
Yeah, but they're opposite of the bisector.
Ooh, okay. Are you talking about the ABC, this information given over here?
Yeah.
Okay, so we know the measure of angle ABC is 72, so let's look at ABC. So ABC is here, and this whole thing is 72 degrees. Oh, these angles would be consecutive, wouldn't they?
Yeah.
So what do we know about consecutive angles? What do you know about consecutive? Okay, so consecutive angles equal 180. So 72, so measure of angle DAB plus 72, I'm going to say, is 180. Kind of take a shortcut there. So we subtract the 72. So the measure of angle DAB equals 108.
And then the next one's 70.
Which one's? What the next one? Angle ADC
Yeah.
is, okay, let's see. ADC is what?
72.
That is 72. Why is that 72?
Because that one is the opposite. I thought the other one was.
Okay, yeah, because it's opposite. These two angles are opposite of each other. So angle ABC and ADC. Lucas, how you doing? Good, okay. And how about that last one? The measure of angle DAC.
63 minus 180.
Okay, so let me erase.
The interior angle of C is supplementary with
Wouldn't
the
that be that
interior angle
41?
of A.
Okay, so let's see. So we've got DAC. So D to A to C. Okay, say this again now.
The 41's the A.
I thought since interior angle of C and it can be supplementary with the interior angle of A.
It's not true. This is true. But you do know, you did find this angle here, didn't we?
Yeah.
CDA or ADC was, so we know this angle. So I would look at this as a triangle because this angle is 72. The angle above is 63, right? This one says 63.
5,000 minus.
Yeah, so the measure of angle DAC plus 63 degrees plus 72 degrees has to equal 180 degrees because it's a triangle. So 63 and 72 is 135, is that right?
Yep.
Okay, so I'm going to subtract 135. So the measure of angle DAC is 45 degrees. Perfect. Does that make sense? How we got that though? Okay, so Caden, do you see how we still have triangles?
Yeah.
Like I said, the triangles are never going to go away. They really are the foundation, I mean, a huge foundational shape with all the things. Okay, perfect. You guys did awesome. I don't know, getting better. It's like Christmas break was all you needed.
So we can have Christmas break every week.
No,
But
no, no.
that's all we need.
no. All right, so this one, Find the measure of each angle and side in parallelogram JKLM. Okay, so what do you know since it's a parallelogram? What's congruent?
They're parallel.
The sides are parallel. Okay, what else do you know? You said something about congruent. What's congruent?
Opposite angles.
Opposite angles are congruent. Okay, well, that doesn't really help me here. Well, I'm just saying because I don't, like with 7 angle J here, 7A, I don't have an opposite measure. And with angle M, it's 13A, I don't have an opposite angle measure.
You need an opposite angle measure.
Well, to be able to solve for A and find out how big it is.
No,
No?
What you're doing though.
because you can just do J plus M equals 180.
Oh, but see, you said opposite angles are congruent, which is true, but that wasn't helpful for solving. But yes, knowing consecutive angles, so angle J plus angle M, so 7A plus 13A equals 180 degrees. That is helpful. Okay, so we're using that consecutive angles equals 180 degrees theorem for this. Okay, so that means we've got 20A equals 180. So we divide by 20. A equals 9 degrees. Okay. So then we can solve for the measure of angle J, which is 7A. So that's 7 times 9, which means it's 63 degrees. And so the measure of angle M equals, do we want to do 13A or do we want to say 180 minus 63? 13A, okay. So equals 13A, which is 13 times 9.
17.
Oh, okay. I heard 17. So 117 degrees.
Well, now you know angle K and angle L.
Now you know angle K and angle L. You got it. So we could also say, so the measure of angle L is what?
63.
63 degrees?
Measure of angle K is 17.
Okay, and we can find those because we know opposite angles. That's that theorem where opposite angles are congruent. Okay, so we can use that one. Perfect. I'm going to slide this over a little bit so I have a little bit more room to work. Okay, so we did each angle. Now it's time to do the sides. So I'm just going to kind of draw a line here to break up our work. So how are we going to find?
2x. Wait, how do you?
Ah, do it. Say it. You're right.
Oh yeah, 2x equals 5y minus 2.
Okay, so we have 2x equals 5y minus 2 because this side is congruent to this side. What would our other equation be?
2x
No,
x equals 2y plus 1.
X equals 2y plus 1. Good, because this side is congruent to this side. Perfect. Now, Caden expressed this growl when he started to say it. Why the growl? Because there's 2 different variables. Bless you. We can't solve it with 2 different variables. However, because we went ahead and wrote them so we could look at them, it's pretty awesome that this one is by itself and we know what x equals. Because there's an x right here, right? We can just put this in there. So we can say, well, this is actually the same thing as saying 2 times 2y plus 1 equals 5y minus 2. And then all of our variables are suddenly y's. We just substituted that in. Pretty sweet deal. Okay, so how do we solve this 2 times the quantity 2y plus 1? distribute. Okay, so
4y plus 2.
we've got 4y plus 2 equals 5y minus 2.
Bring the negative 2 over to positive 2, so 4y plus
So
2,
add 2.
and then take the 4 to the other side.
So then we'll subtract 4y.
So 4 equals y.
So 4 equals y. So now we can solve, like we can plug that in now that we have the y, and we can solve for the other ones.
Okay, do the 2x.
So Lucas, solve for one of the sides for me.
Do that one. Right there.
Okay, so can we do the 2x if we know the y?
Yes. Actually, you can.
Lucas, can we plug y in this expression? Can we plug y in when we have 2 times x? No, so we can't, but the opposite side, which is also congruent, has the y in it. So we can use this one, or we can use this one at this point to solve. So pick one of them and let's find pick one of those expressions and let's find the measure. 5y? Okay, so we're going to do the 5y minus 2. And we're going to plug 4 in. So we're going to have 5 times 4 minus 2. 5 times 4 is 20 minus 2 is 18. So this side is equal to 18. So KL, I should have said this equals KL. My bad. So 18 equals KL. All right, Justice, find JK for me.
Okay, sure. Wait, that's X.
It is an X. So JK, we're going to say, well, JK is actually equal to ML. Okay, and then so we can do ML is equal to 2y plus 1. Right? Okay. So that equals 2 times 4 plus 1. So ML is equal to what, Justice? 9. Awesome.
Wait, so I have a question. With the 2x, can't you solve that? Because you already know what x is. You can do 2 times
What is X though?
x equals 2y plus 1.
Oh, so you're saying could you go back and put y in here? Oh, here?
Like in the 2x.
Mm-hmm.
You make 4y plus 2, and then you can put in the y.
You could, yeah, you could go back and do that and solve for X. But I'm saying you don't have to. You wouldn't have to know the X and the Y. You can make some other conclusions. But yes, you could put this back and say, well, this is the same thing as 2 times 4 plus 1.
So you would be able to solve JM. You wouldn't, like...
You could. Mm-hmm. Mm-hmm. You could solve JM, or you could just say that JM is equal to KL, the measure. So either one of those is fine, which equals 18. So let me take you one step further on this if I asked you. What's the perimeter of this parallelogram? Oh, that was a good way to do it. How would we find the perimeter?
Oh, it would be 54.
Okay. Anybody agree with 54? Because this, again, this is just like a bonus question. How do you find perimeter, Lucas?
You add all the sides.
We add all the sides. So all the sides are 9 plus 18, right? 9, 18 plus 9 plus 18 again. Or I heard some cadence say 18 times 3 because 9 plus 9 is 18. All right, but it equals 54. So again, that's just kind of a bonus. Like we can take it further if we have to find the perimeter or something like that. Very nice. Okay, this next theorem then is the congruent division of transversals theorem. It says if 3 or more parallel lines divide a transversal into congruent segments, then they divide every other transversal into congruent segments. So I'm just going to show you a picture of that. Okay, so here is that diagram. So we've got, and maybe that's too much stuff there. But if 3 or more parallel lines, so we've got 3 parallel lines here, divide a transversal, so this one. Let me clear all this writing off so it's not so discombobulating. Okay, there it goes. Okay, so if 3 or more parallel lines divide a transversal into congruent segments, so these are congruent, right? Then they divide every other transversal into congruent segments. So this transversal here, so this piece would be congruent to this one.
But they're not congruent to the other ones. Right?
They're not congruent to the other ones because the transversal can be going in a different angle, so it could get a different line. But the pieces that it cuts would be congruent. Does that make sense? So if I drew another transversal in there, maybe if I did this one, okay, so this piece is congruent to this piece, right? Because it goes from here to here, and then from here to there, which is a lot longer than the other ones. Does that make sense? Okay, but it's just because if the lines are parallel and you're getting congruent pieces, then they're going to stay parallel no matter what transversal goes across it. So again, that was supposed to be a construction, but I don't see how making the construction would be very helpful. So we bypass that piece. What I do think would be helpful is to go through another problem like this. And so this is actually problem 41 and 42 out of your textbook, but instead of having it for homework, I wanted to work through it together. So it says you would have done 42 because I always assign the odds. So use parallelogram ABCD to find the following. So A, we want the length of each side, and then B, we want the length of the diagonal, of each diagonal when we get there. So let's start off and how are we gonna, because this is what we did on the last one, that kind of substitution idea, because if we look, 6c minus s, this side is congruent to this side, but we have a 7d plus 1. So we have this different variable situation again. So 6c minus s is equal to 7d plus 1. What's my other equation going to be?
7c plus 3 equals 9d plus 5.
Excellent. Okay, equals 9d plus 5, because these sides are congruent. Excellent.
Oh, I remember doing these now.
So which one, which equation is going to be helpful, or?
Let's do the 6c.
The 6c?
It's 6c minus 5, right?
No, it's 6c minus, yeah, it is 5. I don't know why it looks like I wrote an S. It is supposed to be a 5. I was just thinking about that.
Let's say capital S. I don't think we've got this.
Nope, you haven't gotten there.
That far in the alphabet.
Nope, we're not that far in the alphabet. I like it.
Or actually, let's do 7c because they're all positive right now.
Well, I mean, we could do them both. Let's see. How about if I rewrite this one?
Yeah, do the top one.
Let's do 7c plus 3 equals 9d plus 5. Because there's nothing wrong with doing both of them and seeing what you can get, right? Like, all right. So what can we do with this one?
So let's find for C. So take the 5 to the other side, make it positive. Yeah, 6c equals 7d plus 6.
So 6c equals 7d plus 6.
And then you divide that by 6. And then you have c equals...
Okay.
Oh no, you don't have to divide. You can just take it over. Or do you have to divide? Yeah, you have to divide because you have to take the c out. Or the 6 out, so you have to divide by 6.
Okay, so you're trying to get a fraction?
I'm not trying to, but...
I like it. I'm not trying to, but that's what's happening, right? Okay. So yeah, we could divide by 6, and then we'd have C equals 7/6 D plus 1. So do we want to go ahead and substitute that in? Because do you guys know substitution and elimination? I feel like that's like it's something you don't really get until until algebra 2.
We learned part of that last year.
I don't even know what she's meaning. So.
Okay. Okay, because as I say, like we focused on it a lot in algebra 2, but I would not, and that's one problem with this problem, is that's what the book is having you do is a different strategy that I don't think you know how to do. So, it is okay, I want you to see, it is okay if you get a fraction. Okay, like we end up with this fraction. Perfectly fine. We can still substitute that in. It's going to look a little messy, but it doesn't mean we can't do it. So we're going to have 7 times 7/6 D plus 1 plus 3. Does that make sense? Equals the 9D plus 5. So it looks a little hairy, but actually let's solve it. What's 7 times 7/6?
49 over 42.
Okay, so not 49 over 42 actually, because this is 7 over 1. So it's just going to be 49/6 D plus 7 plus 3 equals 9D plus 5. I know, it looks weird, right? Like, I get it. It looks weird. It looks uncomfortable. It's okay, though. It is okay. What is, anybody know what 49 divided by 6 is? 8 and, good, 8 and 1/6 D. So plus 10 equals 9D plus 5. Okay, so how would we solve it? I apparently didn't give you enough room.
You have 5 equals 5/6.
So 5. So you're subtracting 5. Okay, so we got 5. And then you also subtracted 8 and 1/6 at the same time. So 5 equals 5/6 D. Oh, that's a fraction. Okay, how do we get rid of this fraction? Right, because if it's 5D, we would divide. Multiply, what can we multiply by?
6.
We can multiply, okay, we can multiply by 6 because we're dividing. So you can look at it as two different ways. This is 5 times D divided by 6. Or like 5, yeah. So we can multiply by 6 and then divide by 5, or we can multiply by the reciprocal, right? The 6/5 is the shortcut. So the 5s would cancel, and we would get 6 equals D. So we come out with this perfect, beautiful number. We just had a lot of really ugly, hairy work in the midst of it.
That was before it got waxed. Now it's waxed.
Hmm?
So it's all hairy like before.
Oh, it's all hairy like Bigfoot before it got waxed. Okay, now I get it. I was like, before it got waxed, what? Okay, so it is okay. I just wanted you to see, because this problem, I was like, they do not know elimination. I'm not going to assign you this, but I want you to know you can solve it with substitution. It just looks really jacked up for a long time because you're dealing with a lot of fractions. Doesn't make it wrong. Okay, fractions are numbers too. They have feelings, except they don't. And so you can still solve it. That being the case, if we know 6 is D, 7 times 6 is what? We're looking right here. If 6 is D, 7 times 6 is 42 plus 1 is, so this side is 43. Here we have 9D plus 5. 9 times 6 is
54.
54 plus 5 is 59. So that side length would be 59. Okay, so we could do that afterwards. Not a problem. All right, so I'm going to stop us there because, again, this example was more to see, or do you want to go ahead and practice the length of the diagonals?
No.
You sure?
Yes.
Okay, then we'll let you go ahead and get started on your homework.
No.
Yeah, why not? We got 4 minutes. Well, 4 minutes. Well, then let's just go over this problem. We only have 4 minutes left.
No.
If you're not going to start on your homework, then we can go over this problem and talk about it. It'll be okay. You're not going to start on it. You only have 4 minutes. You know you're going to sit there and talk. Okay, so let's look at this. If we want to find the length of each diagonal. If BM is 3x plus 4y, MD is 5x plus 3y minus 1, AM is 6x plus 12y, yikes, and MC is 12x plus 8y.
So how does you say your book is a bunch of letters?
Okay, so we know BM is congruent to MD, right?
Yeah.
Or is equal in this case. They are congruent, but their measurements are equal. So we can set these two equations equal.
Yeah.
Okay, so 3x plus 4y equals 5x plus 3y minus 1. And we could do the same thing.
On that side.
Do what?
Like everything else on the other side.
Say what?
No, take the 3x, take it to the other side. 3y, take it to the other side.
So minus 3x and then minus 3y. I'm cool with that. Well, you said move it to the other side. So 4y minus 3y is y. 5x minus 3x is 2x. These canceled, so we have minus y.
Minus 1.
Thank you, minus 1.
Minus y.
Right? Okay. Then we have AM is equal to MC. Yeah. So we're going to have 6x plus 12y is equal to 12x plus 8y. Good job, Justice. Okay, so let's get our x's and our y's together like we did the last time. So if we subtract 6x from both sides, right, these would cancel. Caden likes to do 2 steps at once, which I don't mind as long as you're showing me. So we could subtract 8y at the same time. So then those would cancel. Are you guys okay with that? You see what's happening? So 12y minus 8y is 4y. 12x minus 6x is 6x. But we know, that's right, we know why, so we can pull that substitution idea in there. Okay, and do that. All right.
So, the whole thing with, like, show your work thing,
Uh-huh.
at the job